In this video, we're going to see how we can set up a four-way movement system in a top-down game while only allowing the player to move in one direction at a time. So let's hit play and we can see what I'm talking about here. I'll hit play and you can see over here in my game screen, we're adjusting the rotation of our player and we're moving our player in one direction at a time. And I can only move in one direction at a time, no matter if I'm pressing an up key, a down key, left or right key. We can only move in one direction at a time. Okay, so how do we make this? Well, first, let's go ahead and get our scene back to square one, and I can take you through every step here. All right, the first thing we're going to do is make sure our camera is set up just the way we want it. So since this is a top-down game, I'm going to move the camera up by about 20 units. There you can see my camera and my scene view over here. And I'm going to rotate the camera by 90 degrees in the X rotation. Okay, with my camera now set up, looking top down onto my playing view, why don't we go ahead and set up our player object. So the first thing I'm going to do is create an empty game object, reset its values in my transform and the inspector. We're going to call this empty game object our player. And then I'm assuming you already have a player mesh. I made one out of simple primitives inside of Unity. And I'm just going to parent my player mesh underneath my player game object. All right. We're not going to worry about attaching any other components right now. All we're going to use is a script that we're going to create. All right. So with my player now created, why don't we move on to creating a player move script. So I'm going to go to my scripts folder in my project window, go to create C# script. I'm going to call this player mover. The next thing I'm going to do is drag and drop my player mover script onto my player game object. And here you can see my player mover script is attached. So why don't we go ahead and get into some code now. All right. So I'll zoom in my code so you guys can read it a little bit easier. All right, the first thing we're going to do is we're going to get rid of that start, and I'm going to get my formatting correctly. The first thing we're going to do is create a public float called player speed. This is how we're going to control the speed of our player. I hit Control S to save, and if I check my game view now, I now see that my player mover script is populated with a player speed float variable. And I'm going to go ahead and set that variable to 5. All right, let's go back into my code. So we're going to be working within our void update function here. This is a function that is executed every single frame of our game. And now we're going to create our input logic so our player knows what button we're pressing. So it's somewhat easy. We're going to do a if input dot get key, and then another parentheses. We're going to do a key code dot a for movement with a WASD input system, and I'm going to close that parentheses. And I'm going to go ahead and make my brackets like so. So this code will check and see if the current player is pressing the A key to move left. And I'm going to go ahead and populate. I'm going to control and copy, Control C to copy that. I'm going to go ahead and use this as a template. Let's do a D. So we're doing our A and D, which is our left and right. And I want to keep copying and pasting that. And we'll do W for an upwards movement. And key code S for a down movement. So these 4 if statements will check for keyboard presses on a WASD type, WASD type control scheme. All right, the next thing we're going to do is create our actual movement of our player. And we're going to do that by directly adjusting the transform position values of our player. So if I select my player and use my move tool, if I move my player to the right, we can see that my X position right here is now at 10 units. So that's what we're going to update anytime we press D on our keyboard. All right, or we'll start with A by moving left. Okay, so what we're going to do is we're going to call a transform dot position, and we're going to plus equal that, and we're going to adjust the vector of this. A vector 3 is a variable that has an XYZ value on them, and we're just going to say vector 3 dot left. That way, it's a quick little shortcut to know that we want to change our vector to the left of our player, and we're going to multiply that by our player speed, and we're going to multiply that by time dot delta time. Not fixed delta time, just regular old delta time. And we'll hit Control S to save that. And why don't we go and test that real quickly? I now can move backwards using the S key. So why don't we use that same logic? I'm just going to copy and paste this line of code. And I'm going to change the vector 3 value for each direction as they correspond to one another. So why don't we go right if we press the D key? And vector 3, why don't we do back? And we'll change the vector 3 here when we press F to forward. So why back and forward? Well, if we look at our game scene right now, we can see that our Z-axis is what controls our vertical movement. If you look at our game screen right here, you can see our vertical movement is actually on our Z-axis and not on our Y-axis, because that's just how we have our camera set up. So that's why we're using forward and backwards with our vectors. I press Control S to save. Now let's play it. Looks like we have those values flipped. When I press S, I go upwards. I really want to go down when I do that. So that's a simple fix. We'll just change the forward and the backward. Sometimes you have to get into the code and see exactly how your keyboard presses correspond to your movement. All right, so here we see a problem. We're not rotating our character in the right direction, and we're moving in 8 directions. So we'll get to moving in 8 directions. We'll fix that problem a little bit later. But why don't we go ahead and fix the rotation of our player here? So I'll bring back MonoDevelop. And it's a similar kind of fix. We're going to do another kind of transform. Dot local rotation. And we're going to set this equal to, we're going to use Quaternions. Quaternions is a type of function that Unity uses to describe angles or degrees, especially useful with rotations. And it takes 3 arguments for our X, Y, and Z. And we want to only rotate our character in our Y-axis. So we're going to leave our X-axis at 0. And we're going to input some rotational values for our Y and leave our Z as 0. Hit Control S to save that. Now when I play my scene, I'm still facing that way, but when I go backwards, you can see now in my transform window that my Y value now equals 180. So we need to go ahead and set those values for the rest of my if statements. And we're just going to be updating our Y value in our Quaternion Euler. This little Quaternion Euler lets us set these values in our transform window, the X, Y, and Z rotational values in our transform component. So I kind of know exactly what kind of angles we need, and you might have to play with it yourself just to get a feel for the exact angles. And that'll be -90. I'll hit Control S. And now when we play, keep your eye on my Y value in my transform component as I start moving around. Oh, looks like we have it backwards again. So when I move up, I'm facing the wrong way. but it looks like left and right's doing okay. So that's a quick fix. All you have to do is flip-flop these negative values. Control S. Now when I press play, now I'm facing in the right direction. So we have a few issues here though. The first being we can move in 8 directions. The second being it's not really rotating exactly how I'd like it to. Like if I start moving downwards, it immediately shifts down. But if I want to move upwards and then go left, it doesn't face left until I let go of the up key. So our rotation isn't quite working as intended. It's doing a pretty good job, but the complications arise if the player is pressing a horizontal key and a vertical key at the same time. The expected results just aren't there. So we need to go ahead and refigure our input logic right here. Right now, we have 4 regular if statements. And these if statements are just fighting for control of what we're doing here. And it's particularly messing with our local rotation. So we need to re-examine our if statement logic here. All right. And not only do we have to fix our if statement logic, but we have to be able to tell if we're moving vertically or horizontally. So we can't move in those 8 directions anymore. If we're moving vertically, straight up and down, we want to lock out all horizontal movement. And vice versa. If we're moving horizontally here, we want to lock out all vertical movement. That'll make sure we can only move in one direction at a time. So to do that, we're going to have to create some new variables here. So let's create another public variable. This time we're going to make a bool. And why don't we call it is horizontal. Public bool is vertical. These 2 bools will act as flags that will tell Unity if we're currently moving horizontally or if we're currently moving vertically, so we can lock out the other direction and vice versa. So next we have to fix our input logic. And since we have these new bools here, we're going to create another conditional check in each one of our if statements. And we're going to do a double ampersand, meaning the conditional check on the left has to be true and the conditional check on the right has to be true. So we're going to say if I press the A key to move left and we're not, that exclamation mark, we're not moving vertical, so meaning is vertical is false, then we can do this code right here. And we have to do one more thing here. If we're currently moving horizontally, we need to set our is horizontal to true. All right. So we're not moving vertically. We're pressing the A key. So both of these conditional checks are true. So we need to make sure that, yes, Unity, we are moving horizontally currently. And then we'll update all of our transform positions and our transform rotations. So we need to kind of update that as we go along. So we're going to kind of mimic some of our code here. Is horizontal equals true. And that takes care of our horizontal movements. Oh, I forgot to add the ampersand there. So make sure you have the ampersand so both of these conditional checks have to be true before we can do this body of code here. All right. And we're going to do something else here. We're going to change my input key code D to an else if. All right. We're going to say if I'm pressing A, then do this code. If I'm not pressing A and I'm pressing D, then do this code. And then we're going to end it with an else, saying if I'm not pressing either one of these keys, else move horizontal, or else is horizontal equals false. So these chained together if statements are saying, okay, I'm going to read it from top to bottom. We know that this is one block of logic here. If I'm pressing the A key and I'm not moving vertically, then we're going to set we're moving horizontally, so that's true. And then we're going to update our rotation position. If I'm not pressing A, but I'm pressing D, Then I'm going to do the same thing for here, but move in the right direction. If I'm neither pressing A or I'm not pressing D, meaning I'm not moving horizontally, I'm not pressing the horizontal keys, then we need to make sure Unity is setting my horizontal to false. All right. So we'll use a little bit of white space to separate these out. So we need to update and do the same for our vertical. So if I press the W key and is horizontal is false. So remember this exclamation mark says whatever the opposite value of this is, meaning is horizontal is false. The exclamation mark basically just means this as well. It's the same difference. It's just the exclamation mark allows me to save a little bit of code there. All right. So we need to come down here and do the ampersand is horizontal. Oh, forgot the exclamation mark right there. All right. And let's do the same thing. We're going to make that an else if. And at the end, if I'm not moving vertically, we're going to say is vertical equals false. So this kind of logic here will activate our Boolean is vertical, is horizontal. It'll allow us to check and see if we're moving vertically, or allow us to check if we're moving horizontally. And it should be pretty good logic. All right. Oh, yep. I got the saved. Unity's compiled. And now I have an is vertical and is horizontal Booleans here. So if I press play, notice how my is horizontal Boolean is checked. Now if I press up on the keyboard, S or D, I'm not allowed to, because is horizontal is true. And if we bring back my code, remember we can only use our W and S key inputs to go up and down if horizontal is currently false, or if is horizontal is currently checked. So as I move left and right, my is horizontal is currently true. As soon as I let go of left and right, that else statement right here triggers, and is horizontal is now turned to false. Same thing with vertical. Well, wait, I'm moving vertically, but I can still move. See, I can move horizontally. What did we do wrong here? Well, we forgot to add this type of logic to our up and down directions. So we need to say is vertical is true, so we can get those flags to fire when we're moving up and down. And by flags, I mean my is vertical and is horizontal Booleans. So with those two lines of code activated, now we can see the logic really at work. So when I move up and down, is vertical is now true, and I can't move horizontally. So no matter how hard I try, I can now only move in one direction. There we go. All right, so the only other thing I can see wrong with my code right now is I'm just repeating the same kinds of calls over and over again. I'm really just being really kind of sloppy with my code. I mean, I'm repeating the same lines of code with maybe just like a single variable different right here in my Y and my Euler and my vector 3 directions. So why don't we see if we can make a move function and clean up some of this code, so I only have to type this code once, and then my move function's called, and it just fires all this code off. All right, so why don't we go ahead and set a move function up. So to make a move function, I'm going to go outside of my void update bracket here. So if I zoom out, you can see that all of this code right here is in my void update. I want to get outside of my void update. I want to make my own void function called move. All right. And I'll set up my brackets. And I've kind of just created my own function the same way that update is now a function. But this is going to be my own hand-rolled function here. So we need to do a few considerations here. Let's look at what types of variables are changing between each one of these key inputs, okay? We see that we set an is horizontal or an is vertical to another value. So that's going to have to be something we take care of in our function here. We change the vector 3 direction, such as vector 3 left or vector 3 right. We change that up per each input. And we also change up the float value of our Quaternion Euler rotations. All right, so we're going to have to pass in these values into my function because they change depending on what key I press. So we need to make my function kind of really versatile and being able to take in a lot of different kinds of variables here so I can use just one function for each one of these inputs. So down here in my void move function, we're going to create 4 variables that we're going to pass in to my function. The first is going to be bool. I'm going to call this horizontal. There we go. I think I spelled that right. Bool vertical. Then we're going to call float angle. And then we're going to call a vector 3 variable direction. So these 4 variables we're going to pass in to my move function so I can really make this function versatile and use it in every single one of these key presses. So I don't have to keep typing out this code over and over again. So what we'll do in our move function is we'll take care of setting these Boolean values right here. So in my move function, I'm going to go all the way down here, and I'm going to say is horizontal, and we're going to set that equal to the horizontal Boolean that we just passed in. These parameters here are local only to my move function. So we're going to pass in a Boolean value called horizontal. Did I spell it right? Yeah, I think so. And we're going to set is vertical to our passed in vertical parameter. We're going to now take care of my position. So I'm going to just copy and paste this code right here down here. But instead of doing vector 3 back, we're simply just going to do direction. This is that passed in parameter right there. Straight in, and it's going to be a really versatile variable because we'll be able to pass in whatever direction we want to into this function. And we're going to do the same thing for our transform local rotation. But instead of putting in an actual 90 or 180 degree, we're going to pass in angle, our angle parameter right here. All right. So my move function is made. Now I need to figure out how to call my move function. All right. So to do that, I'm going to go all the way up to my input key code A. And now I'm going to call my move function. I'm going to leave this code here so I can reference what kind of variables I'm passing in. And when I call my move function, I just type in move. And then I kind of have to see, okay, what kind of variables am I going to have to pass in to my function? So I'm going to have to pass in a true or false variable for my bool horizontal, a true or false variable for my vertical Boolean here, a float, which is this 90 degrees or negative 90 degrees, and a vector 3, which is this vector 3 dot back. Maybe you already see where we're kind of going here. So the first variable we have to define when I call this move function is whether or not horizontal is true. So we'll just simply type in true. So this true value right here comes all the way down here, and it plugs true into my horizontal parameter right here. And then is horizontal now equals horizontal. So it kind of goes like this. We call move. We pass in this true value. It goes all the way down and sets bool horizontal to true. And then we set is horizontal equal to horizontal, our parameter right here. So our variable goes from here all the way down into here. And then this gets passed in to is horizontal. All right. We also need to say, okay, vertical is false. So is vertical will set the false. That's another parameter we're passing in. We'll do another comma. And you can see my pop-up window here. It's telling me, okay, you made this custom move function. Here are all the parameters you just described. Now you have to give me all of these values to satisfy my needs so I can call this move function. So we're going to pass in the value of 180 because this 180, see how it is in my rotation line of code right here? That's the value that we want to pass in to my angle value right here. And then that angle value parameter gets passed right into this line of code right there. Next, we want to pass in one more thing, and we need a vector3 direction. Direction is the name of my parameter. And there's my vector3 right there. So I'll just copy and paste that. Bada bing, bada boom. Now we have called my move function, and we can delete this line of code. So instead of typing these blocks of code constantly, we're just calling this move function, passing in my unique values into my move function, and then my move function is doing all the heavy lifting for me. It's a pretty nifty little way to do that. So I'm literally just going to copy and paste that move call right there and change up the values where I need to. Since this is a horizontal movement, key code D, then yes, horizontal will still be true. Vertical will still be false. But we're going to change my angle of rotation to 0, and we're going to change my vector3 to right. Now I can get rid of that line of code. We're going to come down to my vertical movement now. And this time, since we're moving in vertical, horizontal will now be false, and vertical will now be true. See, these Boolean parameters are now flip-flop because I'm now moving vertically. And I need to turn that angle to negative 90 degrees, and my vector3 now needs to go forward. All right, that's just because I'm copying and pasting that move line of code. All right, and let's call move one more time. In fact, I'm going to copy and paste this because I already have my Booleans flipped. And I'll delete that negative 90. And this time we're going to set our vector3 to back. Now I can even get rid of that line of code. So we have saved so many lines of code now by rolling our own move function. All right, with my move function now created and all of my move functions called in the right places with the right type of values being passed into my move function parameters right here, and with the right kind of logic we've defined, I'm going to hit Control S to save, and it works just like normal. Very nice, very swift, very sleek, very eloquent code right here. All right, so that pretty much does it for moving in one direction in a four-way direction top-down game. If you have any questions, leave them in the comments. Thanks for watching.